So the next idea is what we call exact ordinary differential equations. So it is simply the equation of the same form this is dy. Okay. It is said to be exact when it satisfies certain conditions. M of x comma y dx plus n of x comma y dy. Okay. So the equation, this one, is said to be exact if what happens. So I can go for the proof for that, why that thing happens, but we are just going to discuss the thing superficially for the exam point of view. So you have any type of equation which is given in this form, it is said to be exact when this happens.
Partially
You differentiate m
with respect to y.
partially with respect to
Y.
and it should be same as differentiate n
With respect
partially with respect to
to x.
x. So it's said to be exact when this thing happens. And you can see that if the differential is dx, then you differentiate this quantity with respect to y.
Y.
If the differential is dy, you differentiate this quantity with respect to
X.
x. So you have to see the things as well.
Yes.
The first thing should be dx and the second thing should be dy.
Dy.
And you differentiate this coefficient. This m is called differential coefficient.
Differential coefficient.
Okay, you differentiate with respect to y and you differentiate this coefficient with respect to x. When this thing happens, you call this equation to be
Exact.
exact.
So m of x comma y is general function.
Yes, general function.
Sometimes we are writing with small f of x or small g of x.
It doesn't have any
Doesn't
difference.
matter.
No difference. Because your form should be same. You can name this m to be small f, you can name it to be capital G,
Yes, sir.
or something like that. It's just a name. And what is the method of solution for this? There is a lengthy method, but we are going for the short. You just integrate both of these terms. You integrate m with respect to x, and you integrate n with respect to y. But the question is, you get some constant. Is this possible? Is this possible? You integrate a function of two variables with respect to x. You integrate function of two variables with respect to only y. It is not possible. When you assume something, then you can do.
Constant something.
Yes.
Yes, take
We assume that y is a constant
Here,
here.
here y is constant.
Y is constant.
Here.
What do you assume here?
X is constant.
You take those terms that do not contain x. So terms free of x. This is the method for solving exact equation. It has nothing to do with integral. You don't do this thing always. You don't do this thing always. But this is just the solution of exact equation. So what you need to keep in your mind, three things. What is the form? What is the condition? And how to solve.
Sir.
That's all. And this condition is necessary as well as sufficient. Sometimes it is asked that whether the condition is necessary or sufficient, or only necessary or only sufficient. But this is both.
Both.
ये तो मैंने रोशनी जो ना वही की है कमल की है
Yes.
ये करे चुका था ना
We have done in mathematical thinking.
उन्होंने करे चुका
Yes. But sufficient condition means if you do this, it is done. It will be exact. Necessary means when this is exact, this must be satisfied. But when this is satisfied, it does not guarantee this to be exact. Necessary means this thing. When this is exact, this must be satisfied. But when this is satisfied, it does not guarantee this to be exact. This is necessary condition. Sufficient is when this is satisfied, this will always be exact. Necessary means when this is satisfied, we cannot guarantee this to be exact. So these are necessary and sufficient conditions.
Suppose अगर sufficient होती तो ज़रूरी necessary होती.
No.
Necessary तो sufficient होती.
No. ये
वही
नहीं.
नहीं.
वही. Regular condition जगह strong होती है, it is always necessary and sufficient. बना हुआ necessary बोली.
Sufficient.
Sufficient. Necessary and sufficient, you can think of double implication. A implies B. We have done this thing. A implies B, which is necessary, which is sufficient. A implies B.
Yes, sir.
If a triangle is equilateral, it implies that's a triangle. Obviously, that's obvious. If triangle is equilateral, obviously it's a triangle. So which one is necessary and which one is sufficient?
Necessary is
Left
triangle.
one sufficient ah.
Necessary is
Yes.
triangle.
Left one sufficient थी.
This one is sufficient
Yes, sir.
and this one is
Necessary.
necessary condition.
Obvious ah.
Yes, sir.
But when you have this thing, then this is necessary, this is sufficient, this is sufficient, this is necessary, it means
both are.
both are okay. So this is double implication. Okay, how to solve? Let us take an example. We already have an idea that how to solve it. So just keep these three things in your mind. Let us take an example. There is a lengthy way to solve it as well, but we are not going for that for an exam point of view. So example is 3x square y plus 2 dx x cube plus y dy. So this equation is of this form. You can name this coefficient to be m,
M.
name this to be
N.
n. Now you find partial m by partial y.
Y.
The derivative of y is 1. This is a constant, remains m. The
3x.
derivative of 2 is 0, leave it. Partial n by partial x. The derivative of x cube is 3x square. Y is a constant, so 0. Both are equal, so this equation is homogeneous. Sorry, exact.
Exact.
So the condition is satisfied. Now you are just supposed to solve it.
Solve.
And how to solve? You just integrate your m, that's 3x square plus y, 3x square y plus 2
Y plus
dx
2 dx.
plus integrate. You integrate n, but you take those terms that do not contain x.
Yes, sir.
This term contains x, you will leave it, you will only take this term.
Y.
Y dy equals
C.
constant. Okay, so this is very easy solution. You just take all the terms, but you treat y as a constant. You take those terms which do not contain x. So how to solve this? Just integrate with respect to x.
X cube y.
Just add 1 to the power
X cube y.
x cube y plus the
2x.
integral of a constant is 2x
2x
plus integral of y is y square by 2
is equal to
equals c.
C.
This is our answer.
ये
This is
method का है method.
Asim.
हाँ.
It's in BS Graver.
Grace उन्हें में आना है ना मेरा method में आया. इन्हें में ना.
इन्हें मुझे लगता है h of x
तो ड्रेगा नहीं है ड्रेगा उन्हें.
integration
हाँ?
e power something.
It is. I think we should do that one, but it's okay.
X square. Second term जो कौन है?
Okay, so is this general solution or particular?
No,
General solution involves arbitrary constant. Is this implicit or explicit?
Implicit.
Implicit solution or explicit?
सही मिले ना x और b.
It can
Implicit थी ना.
Explicit can be done explicit.
Common बढ़ाएगा दो से सो. मुश्किल.
1 upon 2
ठीक है तो.
y square
Nothing with the y
plus x cube y plus 2x minus c equals 0. You solve this with the help of quadratic formula. You will get explicit solutions. This is y square. You take the value of a to be 1 half. This is y. You take the value of b to be x cube.
X cube.
And you take this whole to be your c and apply quadratic formula for y. Minus b plus minus square root. You will get explicit solutions. So you can do in that way. It is possible. And it is possible in so many other cases. So you can apply these cases to find out the explicit solutions. It's not a big deal. But this is your solution. Don't worry for that. So the next thing is what we call integrating
Factor.
factors. There are some common notions that we should memorize when we are going for some exams where we expect that there are some questions related to exact equations. The common things are the differential of y by x is x dy minus y dx over x square. And the second thing is differential of x by y is y dx minus x dy on y square. And third thing is the differential of xy is x dy plus y dx. Fourth one is the differential of x square plus y square is 2x dx plus y dy. And differential of log over xy, x over y is y dx minus x dy over xy. And finally, the differential of tan inverse x over y is y dx minus x dy x square plus y square. We are coming to formulas for integrating factors. There are basically two, but there are four as well, but the main formulas are two. But these are general forms.
So dj का है simply differential with respect to x अच्छा है या e?
It's called total differential. You differentiate with respect to x, then you multiply dx. You differentiate with respect to y, you multiply dy. This is total differential. You can prove any of these 6 things, then you can apply these things in your problems. But the good thing is that you can memorize these things easily. It's not a big deal. If there is tan inverse, you have x square plus y square in the denominator. You have log, you have xy. You have y in the denominator, you have y square, you have x, you have x square. These two are very easy. We can prove any of these things. Like, if you take, for example, this one, then how to prove this? You differentiate this quantity with respect to x. Whatever the answer comes, you multiply by dx. And you differentiate the same quantity with respect to y, you multiply dy. This is the idea behind that. You multiply this thing with respect to x. So the first thing is, the derivative is 1 over 1 plus, whatever the angle is squared. It means x square plus upon y square. Multiplied by the derivative of this angle with respect to x. that would be 1 upon y. Now you differentiate same thing with respect to
Y.
y, so you get the same thing, 1 plus x square over y square, and you differentiate this interior quantity with respect to y, that becomes minus x over y square.
Minus.
Now you solve these things. Okay, here the LCM would be y square.
Plus x square.
You can take it in the numerator, I think,
Yes, sir.
and this will be y square plus x square times 1 over y
Another y.
dx, plus you can do the same thing, y square would be numerator,
Yes.
and y square plus x square times minus x over
Y square.
y square dy. 1 y is cancelled, you are left with y dx over, you can write this x square plus
Y square.
y square, and y squares are cancelled, you get minus x dy over x square plus y square, and if you take the LCM, x square plus y square, y dx minus x dy, which is same as this. So you can prove these things easily, but the good thing is that we can apply these in so many problems if we remember these. Let me take one of the example, which will be very short. Y dx plus x square y minus x dy equals 0. What you need to do, you have to manipulate this so that you may create either this form or this form or this form out of these all. You have to manipulate this equation. Then if you got, let's say, this form, then you can replace this with this. Then when you integrate, the integral and differential cancels out and you are done. So how to do this? You can see this is y dx plus x square y dy minus x dy equals 0. If you take these two terms, where do they appear? And I am going to keep them together, y dx minus x dy.
Second.
Y dx
Second.
minus x dy. I think this is that.
Yes. Not.
Y dx minus x dy. This is also that.
Yes, sir.
And y dx, but this would not be minus. This is y dy. Y dx minus x dy. Yes, this is also that case. Y dx minus x dy. So these all are the cases except these two.
Yes, sir.
Except these two. But we have to look at the things. Yes. When you take this thing on another side, this becomes x square y dy in negative sense. Then you divide this x square. Then this becomes y dx minus x dy divided by x square equals minus y dy. Now x square y dx x dy, but negative is in middle. So you have to just swap these terms by taking minus common, then this becomes minus and this becomes plus,
Plus.
and this form is exactly the first one. So you are done. So you can cancel this minus on both sides now. So this is differential of y over x equals y dy.
Dy.
When you get this thing, your another side must be solvable. You integrate this, these two are cancelled, and you can integrate this thing easily. And then the integral becomes, this thing would be y over x,
Y over x.
this thing would be y square by 2 plus
C.
c. This is the answer. So we have to just apply these things. And if we don't know these, we can prove these things easily. But at least we should know these things for now and understand the things. now let me write some rules for integrating factors. Rule 1 is you have same differential equation, you know very well, and partial m by partial y and partial n by partial x, they are not equal. If they are not equal, the equation is not exact. And what you do, you just subtract them and divide this quantity by n, and if you get a function of x only, then your integrating factor would be e power integral f of x dx. This is your integrating factor. This is rule 1. And rule 2 is partial n by partial x and partial m by partial y, they are not equal. You subtract them, you divide them by m, you take a function of y only a function of y. Let's say that is g of y only. Then your integrating factor is e raised gy dy. So these are two cases. And what happens when you multiply this quantity with your equation, then your equation becomes exact. So we'll do one example, then we'll go ahead. So the example is, let's take dx plus x over y minus sin y dy equals 0. So what is coefficient of dx? That's 1. So your m is 1 and your n is this whole term. Partial m by partial y is 0, you can see,
Yes, sir.
and partial n by, you differentiate this quantity with respect to
X.
x,
1 upon y.
1 upon y,
Y.
and this thing would be 0.
0.
So you have these two things which are not same, so your equation is not exact. So which rule should I apply here? Either this one or this one.
Second one.
Second one.
Second one.
Because you take partial n by partial x,
Yes.
there is 1 upon y, and this is 0.
Yes.
And when you divide m, that is 1, this only becomes a function
Function
of
of y.
y. So you apply rule 2. Apply rule 2. So partial m by
Partial n.
by partial x minus partial m by partial y divided by m. Partial n by partial x is 1 upon y.
1 upon y.
This is 0. This is 1.
1.
You see 1 upon y, which is only a function
G
of
of y.
y. So your integrating factor is
C power
1 over y.
1 over y.
dy.
Yes, sir.
So this becomes e
Log y.
log y. E and log are reciprocals, are inverse operations.
E.
So you only get y as your integrating.
Yes, sir.
Factor. You multiply your equation with y, then what happens?
Y dx.
You multiply y with your equation, this becomes y
Y
dx
dx plus x.
plus
X.
y cancel x
Minus y.
minus y sin y
Sin y dy.
dy equals 0.
0.
Now your new m is this,
Yes, sir.
your new n is this.
Yes, sir.
Your partial m by partial y is 1
1.
and partial n by partial x, you can see the derivative of x is 1
So 1
and there is no x here, so this derivative is 0.
Zero.
You can see both are
equivalent.
Equal.
This
so equation is
exact.
exact and it can easily be solvable by integral y dx plus
y dx
integral write those terms
3 over
free from x.
x minus
So
y
minus y
sin y.
sin y dy equals constant. We are integrating with respect to x, so this is a constant.
X y
Integral dx is
x y
minus,
product 2
here we have to apply
product
integration by parts.
parts product yes
Integration by
parts
parts. So u sem
cos y
integral of v
minus
minus cos
yes sir
minus integral derivation of u1, this is minus cos
yes sir minus
So-
minus plus minus
and integral of cos is sin y
sin y.
equals to this one.
So yeah.
This is just integration by parts, nothing else. So we should always remember these two rules for integrating factors as well. You find these, you multiply with the equation and you get exact equation back. The next thing is what we call linear equation, also called Leibniz equation.
Like
And this is one of the simplest equation and the first linear equation that we saw. I think these equations are first order, but they are not linear
not dinner
because of sin y and upon y and so on.
y
So linear, also called a Leibniz equation. That is the equation of this form: dy by dx plus some function of x times y equals some function u of x. We can discuss more about this, but we are just discussing superficially that what we should do when we go for an exam. So this should be function of x explicitly, this should be function of x as well.
so
The integrating factor for this equation is e power integral p of x dx. This is what we call the integrating factor. And the solution would be simply y times integrating factor equals integral
q of x
q of x times
into
integrating factor dx. You can add plus c as well right now. So you only need to keep these things in your mind. You are done. You have a differential equation that takes this form. If it is not of this form, you can reduce it.
reduce
And you have integrating factor, keep the formula in your mind, and the next thing is that you have the solution. That's all. Now the thing is that sometimes what happens that you cannot write explicitly your equation is dy by dx. Then you write as dx by dy. You consider x to be dependent variable and you consider y to be independent variable. So let us take an example in this case and you will see that how it is very much easy to solve such related examples. So it is x minus 1 raised cube dy by dx and plus 4x minus 1 square y equals x plus 1. So is this linear?
yes sir
Yes, we have to compare this with this one. If it is not, then what can we do? So what can we do in this case?
x minus 1 taking dividing both
This
sides
is the general form. The general form of a linear equation is a naught of x dy by dx plus a1 of x y plus a2 of x equals 0. This is the general form and this is called standard form of linear or Bernoulli's equation. You have some function dy by dx, you have some other function of x times y, you have some other function equals 0. Now what you do, you take this function on this side and you divide a naught with everything, you get this thing.
Yes, sir.
This is called standard form. You do the same thing here. You divide x minus 1 whole cube with every term, then this becomes dy by dx plus 4 upon
x minus 1.
x minus 1 times y equals x plus 1 divided by x minus 1 whole cube. This is your p of x and this is your
Q of x.
q of x. Your integrating factor would be e power integral p of x dx. Take 4 common. Integral dx over x minus 1 is log
X minus 1.
x minus 1, and you take 4 into the power of x minus 1, and e and log are going to be cancelled. Your integrating factor is x minus 1 power 4. So this is your integrating factor. You just substitute everything in this formula. You should memorize this standard form structure. Integrating factor, this is the first thing, this is the second thing, and third thing is the formula. So
Yes, sir.
that's all. So solution is y times integrating factor, that is
X minus 1.
x minus 1 whole power 4 integration q of x. What is q of x? Q of x is always this.
Yes, sir. X plus 1 upon
X plus 1 over x minus 1 whole cube times this x minus 1 whole power 4 dx plus c. Just solve these. So y times x minus 1 whole power 4, you can see these are cancelled out,
x square minus 1.
and this becomes x square minus 1 by applying difference between two squares.
Yes, sir.
Then this becomes x
X
cube
cube upon 3 minus x
upon 3
minus x
minus x plus c.
plus c.
Then the solution to your differential equation is x cube upon 3 minus x plus c divided by x minus 1 whole power 4. And after a linear equation solution, you always get an
Explicit function.
explicit solution.
Solution.
If you have some good equation, you always get some explicit solution for that. Where this solution is not valid.
सर with your permission,
Yes, sir.
ऐसा कहीं हमारा है खरी हुई ये जो
Okay, so the next equation after linear or Leibniz equation, we saw what is the general form for that and what is the integrating factor and how to solve it. The next one is what we call the Bernoulli equation, which is the non-linear equation.
Non-linear equations.
The first thing is that it's a non-linear equation. It is same general form dy by dx plus p of x times y equals q of x times y raised to some power of n.
Yes, sir.
Where this n
Not
should not be
not equal to
0
0
or 1.
or 1.
If this takes 0 or 1, then we can get some linear
Linear
equation.
equations greater
Because
than
if the power of n is 0, then the value of n is 0, then y power 0 is 1, this becomes
only function of
cancelled
x.
out. So n is equal to 0 implies that this equation is
Linear.
linear, and n is equal to 1 implies that this is separable. You put n is equal to 1, this becomes y,
Yes, sir.
you take p of x y here, you take y common, divide on their side, this becomes separable.
Separable.
So if you have value of n to be other than 0 or 1, then we can talk about the solution of this equation. So keep the general form in your mind and what are the conditions for that, And when these conditions hold, we get linear and separable. The next thing is that how to solve it. How to solve this differential equation. So the method for solution is, first you convert this equation into linear equation
Equations.
by applying some transformations. And you take y, give it power 1 minus n, make it equal to some other variable, let's say z, and when you apply this transformation, this equation will be a linear equation. And after that, you know very well how to solve a linear equation. Good. So this is the method to solve this particular equation.
Yes, sir.
So you are given a Bernoulli equation, you just apply this transformation, then your equation becomes a linear equation, then you just solve with the ordinary methods that you have so far.
So for n is equal to 1, this is separable as well as linear at the same time.
Yes, separable as well as linear. When n is equal to 1. Okay, let us take one example. dy by dx plus xy over 1 minus x square equals xy raised to 1 half. You can see this is clearly a Bernoulli equation,
Yes, sir.
and this is our p of x, and this is our p of x, and this is y raised to 1 half. So the value of n is
Half.
1 upon 2. This does not lie into these categories,
Yes, sir.
hence it is a Bernoulli equation.
Bernoulli equation.
The transformation that we should do is y power 1 minus
1 upon
n is 1 half, so y power
positive half.
positive half. So this is our transformation. It means z is equal to square root of y, or z square is equal to y. We put these all the things over here, then we also evaluate the value for dy by dx.
Yes, sir.
How to do that?
Derivative.
Multiply with
Derivative. What is the derivative?
2z dz
2z
dz
dz by dx
is equal to dy by
equals dy by
dx.
dx. So let's see what happens after these transformations. We have every transformation at our hand.
Yes, sir.
dy by dx is equal to
2z dz by
2z
dz by
dz by
dx.
dx plus x over 1 minus x square remains n.
X z
Y is equal to
z square.
y is equal to z square equals x. This is y power 1 half,
Only z.
and y power 1 half is
Only
z. Then you cancel this 2z by dividing 2z with every term.
Yes, sir.
Then this becomes dz by
dx.
dx plus this becomes x over 1 minus x square. Z square divided by 2z would be
Only
z
z.
by 2.
2.
So let me give 2 here.
Yes, sir.
Equals x, z by 2z is x by 2.
X upon 2.
You can see this equation is linear.
Linear.
The dependent variable is z
Z.
and the independent variable is x.
X.
You solve it, you get solution in terms of z,
Z.
whatever it is, and you substitute back z is equal to
Half of y.
square root of y. This is your solution, let's say. If you want explicit solution, you just
Square one both sides.
square both sides, because then these things will be cancelled out.
Yes, sir.
So simply the bigger picture is, this is a general form. In most of the exams you are asked what, okay, this is the equation, this is the general form of which equation. Okay, it is Bernoulli, it's linear, it's Ricotti, it's Bessel's or some other equation. They write what is the general form of a Bernoulli equation, they give you different forms.
खास कर ये ना सर if n is equal to 1 या 0 you need to
Yes, yes.
अच्छा
These are the conditions, and what is the transformation that we apply
First this.
to convert this into a linear equation.